Nope. All right. Aluminum is a metal with a high strength to mass ratio and a high resistance to corrosion and is often used for structural purposes. We don't care. Calculate the number of moles of atoms in a 10-gram sample of aluminum. So something I tell the babies is anytime you see grams in a problem like this, you're going to need to calculate the what? You need the molar mass. Now, thankfully, aluminum really doesn't require much calculation, but I want you to write it up here. Al equals what? Because you're going to need it. And moles of atoms is just moles, because atoms is the unit we deal with metals, right? That's the smallest unit. Ionic compounds, what's our smallest unit? Formula units. Covalent compounds, what's our smallest unit? Molecules. This is what I'm talking about here. So this is our symbol. We're going to set this up as 10.0 grams of aluminum. What's going down here? Molar mass, right? And if you wanted to, you could, of course, divide it straight and just put grams per mole, right? Because then the grams cancel, the mole flips up. You get the same answer. So what does that end up with? Point what? 37. 37 what? 06. Okay. And then how many sig figs do we have? 3. So is that what y'all got? First of all, anybody else get something different? That's what I got. And then sig fig should be. Okay, so that should be that. And if you miss sig figs, it's literally just 1 point. Okay? This is why I really recommend you write this down. Throw some extra numbers, whatever your calculator tells you, beyond what you know the sig figs will be, and then round to sig figs. And that way, this is boxed, and I box it like right underneath the number. So if I'm grading your papers later, I'll look at that and go, it's just -1. Okay? Now calculate the number of atoms in a 10-gram sample of aluminum. Now I could, if I wanted to, go all the way back and start here, but why? That wastes time. I would actually grab this number because you get a little bit closer to accurate. So 0.3706 moles of aluminum. Okay, and I need to convert that into atoms. And how do I do that? Avogadro's number. Mole of aluminum. And that's going to equal, what's that equal?
The sig fig answer, is that correct?
That'd be fine. Yeah, absolutely. Absolutely. What do we get? 2.23. Okay. And my guess is if you use this number or that number, you're still going to end up with 2.23. And that's perfectly fine. Y'all good? Questions about this one? Okay, there's definitely going to be stoichiometry on your tests, so be ready for that. Some of y'all got a few of those on this test. Good? Okay. Don't do that.
But it's fun.
He's a nice kid.
Honestly, he's trying his best. You gotta give him a
Yeah.
Yeah, honestly.
That took a little bit. That took a little bit. Thank you.
All right. Isopentyl acetate, the compound responsible for the scent of bananas, can be produced commercially. Interestingly, bees release about 1 microgram of this substance when they sting. The resulting scent attracts other bees to join the attack. So it's good times, right? Calculate the number of molecules of isopentyl acetate released in a typical bee sting. So, I've got grams, right? That means I need to calculate the what? Molar mass. So C7 H14O2, the molar mass of that's going to be what? 130. 130.182. Okay? Why is there an ish? Okay, 1.0 times 10 to the minus 6th grams of IA.
Y'all are nice to honor students. You gave them
What? Gave them the formula?
the.
Yeah,
No,
they,
you gave them the conversion from 1 microgram to a gram.
oh, yeah. It's a rough year. Like, I would not have given them this. Typically, wouldn't give them this.
Yeah, no, you.
Because, but everybody's like feeling sad and sorry, and some of the other campuses are, I know, and so, you know,
I did the same thing.
so I get outvoted about teaching, this stuff.
You should just. It's not like I need to know.
So, I need to go from grams. So what do I put down here? 30.182 grams of IA, and that is 1 mole of IA. Okay, that gets me to moles. Did I ask you for moles?
No.
Asked you for what?
Molecule.
Molecules. So again, we're going to put 6.02 times 10 to the 23rd. He's dead.
My man, avocado.
Okay. Y'all good? We did a little punchy. What do we end up with? 4.6 times 10 to the,
So I can buy these commercials.
oh yeah. Yeah, you should order on Amazon.
You just want to snort banana powder?
No, I was gonna put it in a spray bottle next to a beehive, and then
That's a very-
spray somebody.
On your little sister?
That's a very specific revenge plot.
Yeah, well, they'll just go kind of a little crazy.
Banana girl.
Yes, you should say bees. Bees are tasty. All right.
So bees just smell bananas and they go crazy?
It depends on the type of bee. All right, y'all good? Yeah, see, this is another perfect example. If I gave you this question, I would not give you the reaction.
You also wouldn't, I feel like there would be a lot more in that blurb. It would be like, Bobby was walking down the street and da-da-da-da-da.
Right. Well, because that's what your test is going to be, right?
Yeah,
It's
it's
this
gonna be
giant paragraph. You need like 4 words out of it.
So solid lithium hydroxide, carbon dioxide, boom.
Right.
Liquid water.
Solid lithium hydroxide is used in space vehicles to remove expelled carbon dioxide from the living environment by forming solid lithium carbonate and liquid water. Which is kind of cool because then you can use the liquid water as well. Okay? So you need to balance this equation. How do we do that? Super hard.
Balance it.
Count them.
2, 1, 1, 1.
Is that right?
You know what, Brendan?
Still got the answer, but you could divide all those.
What mass of gaseous carbon dioxide can be absorbed by 25 grams of lithium hydroxide? So I've got carbon dioxide, lithium hydroxide, and I've got mass of carbon dioxide and grams of lithium hydroxide. That means I need to find the what?
Molar mass.
I need the molar mass. So our good friend CO2, what's that? This is probably another one of those like water that's going to stick in your brain pretty quickly, and then you'll have it. And lithium hydroxide, that is, okay, that'll take care of that. So I got 25 grams of lithium hydroxide. Okay, I need to convert that into what first? How do I do that? Then I need to do the magic, right? What's the magic? I need to convert Mole ratio, right? So moles of LiOH and moles of CO2. What number goes here? Abby? What number goes here?
I mean, look.
Everybody okay? Questions over here? Y'all good? That gets me to moles of carbon dioxide. That's not what I asked you. I asked you for what? All right. Do a little punchy. What do we end up with?
Approximately 23 grams. Between 22.97 grams.
Good deal.
Is that what it is? What did you say?
Yeah. So it should be 22.97.
Oh, that's gaseous. Gaseous. Why does that matter? Oh,
Okay, so let's do a little quick estimations. So I've got 25 divided by 24 is pretty close to, but a little bit more than 1. Divided by 2 is half. Half of 44 is roughly 22. I know it's going to be somewhere a little bit more than 22. And sure enough, your punchy tells you that, right? Yes, we can all be excited about that. Oops, there we go. Nitrogen gas can be prepared by passing gaseous ammonia over solid copper 2 oxide at high temperatures. The other products of the reaction are solid copper and water vapor. So the first thing we need to do is balance this guy. All right. How do we balance this? 2, 3, 1, 3, 2. Did everybody get there? Yes. Oh no, that's fine. That's I do that for stoichiometry problems to make it easier to see.
H2 is 3.
What?
H2 is,
This one's supposed to be 3, right?
yeah. Okay, I don't
Well, we're going to check it here. How many nitrogens do I have now? 2. And over there I've got how many hydrogens?
6.
Over there. Coppers?
3.
Over there. Oxygens?
3.
Good? Looks like fun, right? All right, a sample containing 18.1 grams of ammonia is reacted with 90.4 grams of copper 2 oxide. Let's circle the limiting reactant. In order to do that, I need to do a few calculations. Right, so some of y'all know the shortcut. If you don't, you're going to learn it right now. The way we told y'all back in baby was just take the whole thing and run the whole reaction twice, right? And that makes sense if you only got 2 reactants. You know, you'll save a little time with this shortcut. But particularly if all I ask you is what the limiting reactant is, which often that's the question, the shortcut will save you a lot of time. So let's go through that. First of all, I see grams of and grams of. Okay, so I need to calculate the what? Molar mass of ammonia is? And the molar mass of copper 2 oxide is 5.5 grams per mole. All right. Here's what we're going to do. What I need to know is not how many grams, but how many moles. So let's do this. Grams per mole. Okay, we'll do this too. This is 79.55 grams per mole. Okay? Who's got this for punchy? Who did that? What you got?
Oh, you mean, okay. 126.8.
No.
It's like 1.06.
Punch it in.
I converted it into moles of N2 to find the limiting reactant.
Yeah, so I did too.
Moles of N2? I thought you meant like.
This step right here. That's what I want. 1.0. Keep going. Give me some numbers.
1.06
moles of NH3. What about this one? What is this one?
Oh,
Slightly larger.
1.1364.
So I have 1.0626 moles of ammonia, and I have 1.1364 moles of copper 2 oxide. All right, I'm not done yet. I want to be clear. What I do want to do is compare the ratios of these two things. So the way to do that is to divide by the coefficient. Divide that by 2 and divide that by 3. What does this equal? Punch it in.
0.56.
Give me a few more numbers.
Point-
Actually, no, this one doesn't matter. 0.56.
3, sorry.
5 what?
0.5313.
5313. And this equals 3 what?
It's 0.379. That's the first 3 digits.
Okay. Which one of those is smaller? 0.379. So that's my limiting reactant. That's all I have to do. I don't have to do the whole stoichiometry. I don't have to get to the end. That's it. I know this is the smallest. Y'all good? It's a nice little simple step. Again, for 2, is it really worth the time? I don't know. Because the nice thing about doing it the long way is you also answer the second question.
Well, unless you use H2O. Unless you were Emma.
There are,
Instead of going to
you know, I
yeah, water.
There you go.
I was gonna get there. Don't worry, guys.
it's about all I can do. All right. So now I'm going to come back to here. Since this is my limiting reactant, I'm going to take this number. Guess what? I've already gotten it to moles. Moles of reactant, which is 1.1364 moles of CuO. Now I need to convert that from moles of CuO to, well, first of all, I need to go to moles of,
First, you need to go to moles of
yeah, there we go. So moles of CuO. What's the number in front of CuO?
3,
N2?
1.
Okay. That gets me to moles of N2. That means I need the is, okay. And some of y'all realize you could do some combinations of stuff, but that's okay.
Is it okay if I just did 28?
Yeah, I'm guessing the sig figs aren't going to matter. So here's the deal. When you're doing multiple choice, that's perfectly acceptable. Drop that stuff off. It's not going to matter. It probably won't matter in terms of free response. Like, there's no way in the world they're going to take off. Okay? It's just they're not going to do it. As long as you're writing down what you're using, people are going to see that. I do some punchy. What do we end up with? 10.6 grams of N2. Y'all good? Any question of that? Any questions? You good? Any questions? Is that what you got?
No, but I know what I did wrong.
So you know what you did wrong. Okay, mark it up. I will give these back to you next week after all my babies have gone through it. So y'all,
I haven't even taken this yet.
no.
Are we your guinea pig?
Yes, I wrote it this morning, so I needed to make sure it worked.
Okay, so change it up. Get rid of the equations. Make them start from scratch.
No.
Lame.
I have a version like that for next year, but yeah.
I feel like we did stoic a lot sooner.
You've already done like thermochem.
No, we have not. That's coming next. So we're going to do a test on the 22nd, and then we're doing thermo.
Yeah, we were like on the very beginning of
Well,
stoic.
we were
No.
dimensional analysis. That's what it was. So
Yeah, no, they've been doing dimensional analysis since the first week of school.
Yeah, not stoichiometry.
Or no, I mean the first week we were back in person. We did a little 8th grade review while y'all were virtual.
And then we did spring break, and then after that, it just went to.
Yeah, and then none of y'all wanted to work, and it was crazy. All right, methanol, also called methyl alcohol, is the simplest alcohol. It's used as a fuel in race cars as a potential replacement for gasoline, not. Methanol can be manufactured by combustion of gaseous carbon monoxide and hydrogen. This is a super hard one to balance. Did y'all get it? Did you balance it? All right, 1, 2, 1. Okay. Calculate the theoretical yield when 68.5 kilograms of carbon monoxide is reacted with 8.60 kilograms of hydrogen. Again, I see grams. That means I need to calculate the what? So CO, again, is, what's molar mass carbon monoxide? 28.01. Okay, and then H2, really hard one. And we're going to need methanol, so let's go ahead and do that. 32.0 what? 42. Good. Everybody okay with that? So if I've got two reactants, that tells me this is going to be what kind of a problem? It's a limiting reactant problem, so we're going to do the same thing. So you may have done it a little differently. What I did is, in my mind, went ahead and converted this to grams. Some of y'all may have written that into your dimensional analysis. That's perfectly okay. It's also perfectly okay just to do it in your head real quick. Okay? So let's try this. Let's make sure our heads are working. So 68.5 grams of CO, and our molar mass is 28.01 grams per mole CO. So how many moles of CO do I have? 2,000 what? 445.56. Do the same thing here. 8,600 grams of H2, 2.016 grams per mole. And that's going to equal what?
4,264.65 moles.
Did you get 4 point something?
I divided it. I didn't write down an interchange.
Okay. So this is a stage I would encourage you to throw some extra digits on. It's not a sig fig stage because that's not a stopping point. We only do our sig figs all the way at the end, right? That's fine. All right, so that gets me to the moles of each. And a lot of times as soon as you get to the moles of each, you can kind of eyeball it, but not in this case. It's too close. So this one you're going to divide by what? 1. This one I'm dividing by 2. Do y'all see what we're doing here? I'm taking these coefficients and dividing because I need to know they're relative to each other. So this one's real hard. This is, 2, 4, 4, 5.56. This one's going to be what, though? 9.4. Right? So which one of those is smaller? Hydrogen. Hydrogen's our limiting reactant. I didn't ask you to circle it, but it helps sometimes. So now I'm going to take this value, 4,265, and I would use whatever your calculator spit out for that. But you don't have to write it again because you already wrote the math. Okay? Now I need to do some magic and convert moles of hydrogen into moles of methanol, right? And the number for hydrogen should be, and now I need to convert moles of methanol into grams. So 1 mole of methanol is 32.042 grams. Okay, that takes care of that and that and that and that. And I go through all that and I do some punchy, and what do we end up with? 68,300 300 grams. And I could write this in scientific notation as okay, and that's my 3 digits, so we're good there, right? All right, I've got this number now. I'm going to hang on to it. Either one of those is acceptable. It does not have to be in scientific notation. We just have to have the right number of sig figs. Good? Everybody follow? All right. Now let's take the next question. If 3.57 times 10 to the 4th grams is actually produced, what is the percent yield? So just like when we have an exam, your answer is the number right, the number right divided by the possible numbers. So the number right in this case is 3.57 times 10 to the 4th grams divided by 6.83 times 10 to the 4th grams, blah, times 100%. Okay, the 10 to the 4ths cancel out, and so now you can just do 3.57 divided by 6.83, a little more than a half. What do we get? 53 point what? 52.3. Is that what you got? Okay. Good. All right. I saw the consultation in the back. That's often helpful. Has messed up your idea of math. Yeah, it has a way of doing that.
Yes.
Yes, he did.
I did that at first.